Right, welcome back. Section 2.1, linear equations is what I'm going to be discussing in this lecture. And in section 2.1 we are talking about linear equations. We've got a couple of examples of linear equations. In this course we are talking quite a bit about different types of equations. This one in particular type of equation is linear equations, and by linear equations what distinguishes it from other equations is the power. Linear equations, linear refers to degree 1 or first power equations. If you're familiar with that, yeah, degree 1 meaning the power. Power is 1. I've got a couple of examples here on the board of linear equations, and notice both of them do have power 1. There's no power showing on the variables, but that power is understood to be a power of 1. So we want to talk about solving different linear equations here in this case. Now, we do want to solve these. Probably somewhat familiar with that, but let's just go over the basic ideas here. Let's start with the first example here on the left. 2x plus 5 equals negative 7. Solving linear equations, basically what that entails is solving linear equations means get the variable on a side by itself. Isolate the variable on one side, right? To solve a linear equation, that's basically the idea. We want to take 2x plus 5 minus 7, and we want to get the variable x on a side by itself. Isolate that variable, we call it. Well, we do that through various techniques. And most basic rule of thumb in solving equations is what you do to one side, do to the other side. So I want to take and do the same thing to both sides and try to work my way to get x on a side by itself. Well, what I need to do is basically to get x by itself is get rid of this 5, get rid of this 2. And the way we do that, of course, is by doing the inverse operation of each of those. This is plus 5, so to get rid of it on both sides of my equation, subtract the 5, right? So we subtract the 5 from both sides. Now, when we do that, this side becomes a 2x, because a 5 minus a 5 gives you 0. Negative 7 minus a 5, well, combine those, you get a negative 12. So we work our way down. We've got a little simpler equation now. 2x equals negative 12. We're almost there. Well, that recognizing that is 2 times x. That times doesn't show up, but is understood to be there. So to get rid of the 2, we do the inverse operation of times, which is divide. So we divide both sides by 2. Again, basic rule of solving, do the same thing to both sides. So we divided both sides by 2, which gives us an x equals negative 12 divided by 2 is a negative 6, because those 2's, right, those cancel. 2's cancel out, and our solution then is negative 6. That's our answer, or the solution. Now what does that mean? Well, that means solution to the original equation. What we've done is we've figured out which variable or what value of the variable works in this particular situation. 2x plus 5 equals negative 7. Well, it has to be, x has to be a negative 6. So we say the solution is negative 6, x equals negative 6. Lots of different ways we can say it. We can write it in set notation this way. So any way you go, that's the value that we need. All right, so let's look at example 2 over there because that's an example where we have variables on both sides. Well, the thing is, when you have variables on both sides, you are going to need to get the variables to be only on one side. So yeah, I need to get the variable terms on one side, and then I'm going to take the constants, the terms without the variables, to the other side. I'm basically going to do a little swap out here. Swap out, move the 2p to this side. I'm going to take the minus 5 and kind of go with it to the other side. Well, to do that, of course, we have to follow the rules that we can. To move 2p, we need to subtract it. 2p minus 2p, well, that would be 0, so that's going to get rid of it on the right side, but I have to do the same thing. Do have to do the same thing to both sides, so subtract 2p from both sides. 6p minus 2p, well, that gives me a 4p. Still have the minus 5 on the left. But yeah, 2p minus 2p, that's 0. That term has disappeared from the right side. So all I have on the right side is the negative 11. Okay, well, we said, yeah, we have to get the constants to the other side, so I'm going to move that 5. I'm going to add 5 to both sides. Yeah, it's a minus 5, so I do the inverse of that, which is adding. So I would add 5 next step here to both sides. What happens on the left? What happens on the left is we'll just have 4p. Minus 5 plus 5, that's going to be 0. So 4p is all we have on the left. Now, negative 11 plus 5, combine those, yeah, you do get a negative 6. All right, well, we are trying to get p isolated, so we still have to get rid of that 4. It's 4 times a p, so to get rid of the 4, we divide by 4. That'll cancel the 4's out and leave me exclusively p there. All right, now, the other side is a negative 6/4. Talk about that answer for just a second. What we'll be looking for on that, of course, is does reduce. We've got a common factor of 2, so I'd want to reduce those by 2. 3 on top, 2 on the bottom. Reduce the 6 by 2 and the 4, reduce it by 2. So I get p equals negative 3 over 2. All right, so that's my solution value right there is negative 3/2. We also might note we could very well write that as a mixed number, negative 1.5. That would be a perfectly fine answer. Or we could also write it as a decimal, and as a decimal it would be a negative 1.5. Okay, negative 1.5. Any of those answers, valid answers there. Okay? All right. Let's take a look at another couple of problems. Various problems we could encounter as we work through some of these. Let's take a look at a couple here. 3y minus 7 minus 9y equal 12y minus 5. 3y minus 7 minus 9y equals 12y minus 5. Very similar to the previous one, but I do have one thing on the left that I didn't have on the left a while ago. Yeah, I've got like terms on the left. And anytime you have the like terms on one side, you will want to combine those. 3y minus 9y. Combine the like terms here. That's my first step. 3 minus 9, we just talked about that in 1.4, combining like terms. 3y minus 9y, that gives me a minus 6y. 3 minus 9 is minus 6, so we get a minus 6y there. the rest of it stays the same. All right. Now, another note here we might make is, yeah, we need to get the constants on one side, the variables on the other. What I might note here is, by what it looks like, it might be easier to get these variables to the left side. Notice here, because if I move my 6y term, minus 6y term to the other side, that's going to make everything positive as far as the variables go. So that's what I'm going to do here. I'm going to move the variables to the right, in this case, and then I'm going to take this constant term and move it to the left. Just looks like the numbers work a little bit easier there. That's perfectly fine. So if I do that, move the variable 6y term to the other side. Well, it's minus 6y here, so it'll be plus 6y added to both sides. This side then would be a negative 7. Those go to 0. This side would be 12y plus 6y is 18y minus 5. Okay, well, got the y terms together. Now I need to get the constants together on this side, so I'm going to add the 5, opposite. Negative 7 plus 5, well, that's a negative 2, equals 18y. So in this case, I'm going to get the y on a side by itself, but it's going to be on the right side. All I have to do is get rid of that 18. 18 is times the y, so I divide by the 18. So I get negative 2 over 18. Those 18s will cancel. Of course, those reduces each by 2, so that'd be a negative 1. Reduce that by 2 would be 9, so negative 1/9. So the solution here is going to be a negative 1/9. Similar thing happens here, but has another little twist on it. Let's say 5x plus 4 minus 3x minus 4 equals 6x. Well, again, this one's starting out with, we do have some like terms we can combine up on the left-hand side. We've got a 5x and a minus 3x we can combine. 5x minus 3x is, 5 minus 3 is 2, so it'll be 2x. Your 4 minus 4, that's pretty nice because 4 minus 4 is 0. So here's what we wind up with. 2x equals 6x, and this is why I did want to mention this one. 2x minus 2x equals 6x. In this case, all the variables have disappeared. We have no, all the constants have disappeared. We have no constants left. However, we still are wanting to get the variables on one side. I don't have that yet. I have the variable on both sides. X is on both sides. So I need to get the variable terms on the same side. So how do I do that? Well, I'm going to subtract. One way to do it is I'm going to subtract 2x from both sides. 2x minus 2x, well, this side will just be 0. 6x minus 2x gives me a 4x. So now I do have variables on the same side, or combine those up into one term, which is now 4x. All right, well, this problem is just like the other problems. I need to get x by itself. It's 4 times x. I need to divide off that 4, don't I? 0 divided by 4, well, that's just 0. 4's cancel, so that's just x. Yeah, it turns out my solution in this case is just going to be a 0. All right.